So let's go back to our original question, the increasing trends in PAHs. We would like to know if coal tar-based seal coat is the source of these increasing trends. We now have data for 40 lakes that we used in this particular approach. And this is a paper that has been submitted to Science of the Total Environment, and it should be published within the next couple of weeks. It's gone through the whole review process. What the approach was we took is we took data that we already had for sediment cores for 40 lakes that we'd analyzed. And we're looking at, we have the source profiles that we talked about for all the different PAH sources. And then we have what we're calling receptor profiles. This is a source receptor approach. The receptor is the lake sediments. So each one of our lake samples is a receptor. And we're using a model that has been, it's a statistical model created by Environmental Protection Agency. And what it does is, well, first let me show you a couple of sources. So here's just an example of one of those profiles I was talking about. This is for traffic tunnel air. So this is representing particles, exhaust particles that you would find in a traffic tunnel. And here's an example receptor. This is some sediment from one of our sediment cores, Lake in the Hills, which is outside of Chicago. What the model does is it statistically, you give it the sources and the profiles, you give it the receptors and the profiles, and it figures out for each receptor, each sediment sample, how can we best combine those sources to recreate the sediment. So again, let's go back to our baking analogy. Let's suppose you go out and you have a really fabulous peanut butter cookie. And you go home and you start pulling down peanut butter and flour and sugar and butter in the kitchen. How can you best combine those ingredients to recreate the peanut butter cookie? That's what this model is doing. What it gives you at the end is it quantifies the contribution of each of the different sources that you give it to the sediment sample that you're interested in. So now we're finally getting at quantification. We think that this is an improvement over just the ratio matching that we've used before and that others have used before. It uses all of the PAHs rather than just a couple of them, and it's quantitative. So we ran the model about 200 times. Some of the results, and the CMB model gives you statistical measures of how good the results were. So we picked the best 4 out of those 200 and we averaged the results, and that's what I'm going to show you here. Here are all the different sources that we considered, and we grouped them into 5 categories. Historically, coal combustion has been considered to be a very important source of PAHs in the environment. And so we obtained profiles from the literature for power plant emissions, residential heating, and coke oven emissions. There's also a whole slew of vehicle-related sources. Those are grouped in that category. Third category is fuel oil combustion. Then there's wood burning. And then there's those related to coal tar seal coat. There's a coal tar standard from NIST, but that represents coal tar before it ever hits the environment. And once it hits the environment, it can go through some changes. So we also have had profiles for seal coat products, for seal coat scrapings, the dust from 6 cities. So this is what would be really the mobile part that we would be expecting to wash into the lakes, and then the seal coat dust just from the city of Austin, which is subject to perhaps stronger weathering because of hotter temperatures than some other cities in the U.S. So here's a summary of the results. So these are the average of the 4 best models. What are we looking at here? Across the bottom, we're looking at 40 lakes. And we've divided those into 3 geographic areas: west of the Continental Divide, the central U.S., and the eastern U.S. That's 35 of the lakes. 35 of those lakes are in what we would call urban areas. Urban areas, we're not talking downtown Detroit. We're talking places like Springfield. We're talking places where there's housing developments, commercial areas, strip malls, single-family housing, multifamily housing, basically the kinds of places where we all live and work, but they're not pristine rural environments. The other 5 are large lakes with large mixed land use. So an example of that might be Lake Mead in Nevada. So these are very big lakes with very big land uses, and very big watersheds. We put those in because we wanted to kind of compare those to these smaller urban lakes. And these are The bars, the heights of the bars, are measuring the total PAH concentration. So that's mass loading in milligrams per kilogram there along the vertical axis. And we've divided them by color into these 5 categories. So the seal coat is the orange. It's making up the majority of the PAHs in these 40 lakes. On average, it's contributing about 50% of the PAHs in these 40 lakes. This is for sediment that's been deposited since 1990. Coming in second is vehicles, which is producing somewhere about 23% of the PAHs on average. After that, coal, which is about 18 to 20, and then wood and fuel oil are coming in a distant 4th and 5th. So this is an opportunity to really quantify the importance of these different PAH sources. But what we really wanted to look at was trends. So what we just looked at was recent sediment in those 40 lakes. We took 6 lakes that are in rapidly urbanizing watersheds, and we ran the model for every single sample down the core, and that's what you're looking at here. So we picked 2 lakes from each of our 3 geographic regions. So the 2 on the left are from the west, the 2 in the, no, I didn't organize those very well. That's Town Lake in Austin, Texas. And the one to the right is paired with that. That's Lake in the Hills in Illinois. So those are our central lakes. And then Lake Ann, Virginia, and Lake Killarney in Florida, those are our eastern lakes. And again, same color coding. So the coal tar-based seal coat is the orange. And what we're seeing is that for 5 of these 6 lakes, very strong increasing trends in PAHs. And it's the coal tar-based seal coat that, on the basis of the model, appears to be responsible for these trends. Now, the outlier is Railroad Canyon Lake in California. This is in a suburb of Los Angeles. There, not entirely surprisingly, because they don't use coal tar-based seal coat, and there's a lot of cars, the vehicles are accounting for most of the PAHs, but look at the concentrations over there on the vertical axis. The concentrations in that lake are about 100 times lower than they are in Lake Ann in Reston, Virginia. And Reston, Virginia is a very upscale, planned urban community. It's not a big, yucky industrial area, but it has concentrations that are about 100 times higher than they are at Railroad Canyon Lake. So it appears that it's not just the density of urbanization that is causing PAH contamination. Let's wrap up here by doing one more paired comparison. So let's take a look at these 4 lakes, 2 in the west, 1 in the middle, 1 in the east. So we have Tanis Brook Pond in Portland. It's a suburb of Portland, Oregon, and there's a population about 844 people per kilometer, kind of middle density, big highway going through the watershed. And here's Palmer Lake, which is in Minneapolis, Minnesota, very similar density, also similar highways. PAH concentrations are about 25 times higher. Here's Decker Lake. This is in Salt Lake City, not known for the best air quality in the world. It's got a major interstate running through the watershed, about very dense, 2,000 people per kilometer, PAH concentrations of less than 1. Lake Ann in Reston, Virginia, similar population density and about 23 times higher PAH concentrations. So the evidence is that it's not just urban density, and it seems to really jive with the results that we've gotten from this modeling.